Continuing on with class 4, here's concept application 2.4. We're given that we have a force of 500 newtons. So that's the magnitude. We're also given theta x is equal to 60 degrees. Theta y is equal to 45 degrees. And theta z is equal to 120 degrees. Now, something that you should know, you can't just pick random. Whoever created the problem could not just randomly pick 3 angles. There's only so many angles that there's only one angle after you've chosen 2 that one or two possible angles that you could pick. And that's because of this relationship right here. We want to remember that theta x and theta y combined with theta z have to have this relationship right here. That's one of the reasons why is because they're orthogonal, right? So once you knew that it's 2 angles, the third one can be either of 2 angles. You notice that they're squared, so in the process we take a square root. That means it's either plus or minus the answer, right? So when we have a plus or minus answer, we have 2 possible things. So that actually ends up meaning it's going to be the same line in space, but that plus and minus decides whether it's going to be in the positive or negative direction. So just be aware of that. It's not something that comes up in this problem right here because they've given it to us. But if they only gave us 2 angles and we didn't have a third, we can find out that third one, or at least 2 possibilities of that third one. Okay, so but what we're looking for here is simply fx, fy, and fz. So this is really kind of straight ahead right here. All you need to do is plan out fx is equal to f times the cosine of theta x, right? So that's 500 times the cosine of 60, or 250.0 newtons. Fy, and remember that just comes from these up here, right? These equations right up here. And Fy is equal to f times the cosine of theta y, or 500 times the cosine of 45, and that ends up equaling 353.6 newtons. And then lastly, Fz is equal to f times the cosine of theta z, or 500 times the cosine of 120. Now you notice that's greater than 90, so we can expect to get a negative answer, right? So writing out the answer for this right here, and I don't think they did in the book, we would want to properly write out that it's 250.0 I plus 353.6 J plus negative 250.0 K, and then call it newtons. And it might make us feel a little better about this if we were to try our best to make a sketch of what that might look like, right? And a lot of times I like to extend it to the negative directions. And it'd be good if we could keep a bit of a scale to this. So let me make these only a light blue. We see in the x direction we get 250 right there. There's the fx. We can see in the y direction we get a little bit taller, but in the z direction we're going negative right there, right? So if we could take parallel lines, we can make a box. Should be parallel to that. It's parallel there. Here we go. Draw a line up. Let's draw a parallel. So we're making a parallel cube right here, right? And we want to try to find that far away point, and that's the vector. It's often good if we could do this in like a graphics program, so we could rotate this thing around, because unfortunately the way things worked out in the magnitudes, the final vector f is kind of overlaying the fz right here, right? So this is fx, fz, and fy. By doing that, it helps you give you sort of a sense of what's actually taking place. And now let's go to the other concept application. This is really going the other direction, and it's relatively simple right here, right? That we're given fx is equal to 20 pounds and fy is equal to negative 30 pounds and fz is equal to 60 pounds. Right there, right? So we want to find the magnitude of f, and we want to find theta x, theta y, and theta z. Well, it's not too terribly hard. We say 20 squared plus, that's a 20, not a 26. Negative 30, but it's squared, so we didn't even need to write down the negative, and 60 squared. And if we do that, we get 70 exactly. But I'll go ahead and put 4 sig figs because we're stating that yes, it is exact, well, at least up to that many. And then we come up with, so let's see, in terms of equations, what we've used is we used this right here, and now we can simply use the backwards way of these, which are defined right here, right? So just take the components divided by the magnitude and take the inverse cosine. So theta x is the inverse cosine of fx over f, which is going to be, right here, is going to be 20 divided by 70, and we get 73.40 degrees. Theta y, got to be careful here, right? So I'm writing out the equation, but putting the numbers in. It's really helpful to do this. We get a negative 30 divided by 70, and we end up with 115.4. We expect something greater than 90 because it's a negative value, right? You can picture that's becoming, it's because it ends up being onto the other direction of the axis that we're referring to. And then theta z is going to be equal to the cosine of fz, whoops, over f. So you take the inverse cosine of 60 divided by 70, and we're left with 31.00 degrees. So these are the answers, and if I was going to have this was going to be a homework problem, I'd ask you to rewrite these out and then box them up. But let's not do that here for brevity's sake. If we were going to take a look, and let's make really light lines, dot, 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 dot. And then put in the components of this right here, we could see that the components were 20, right? Here's 20. Here's fx, right? 30 was negative y right here, right? So, or y was negative 30. So, and then z was much larger than the other two. I guess I'd keep going with this color. It was like right along there. I guess it was different color. fz. So dot 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 dot. Whoops! Oh, I made this thing much bigger than I. Okay, stop. Okay, it won't let me draw now. And I lost my little thingy. Come on. There you go. Back to you. Dot 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 dot. So I kind of like picked a bad spot for it, but you could kind of see that it's going to come down and go towards that right there, right? So that's going to be our f vector, and there's our fy as part of that. So it's good to try to picture those. So I'll see how long this took, and I will discard all of that nonsense, and it's a 10-minute video.